Alright guys, so we are on page 97 in our workbook, and this is what we were supposed to do in class on Thursday. However, we worked on our test some more, so I'm going to go ahead and do this video, and that way you can work on it Friday at home. So, first, we're going to sketch a new graph, alright, and it gives us 5 characteristics. So first, the easiest characteristics for us to put on the graph is a point that is -4, -8. Okay? The next easiest characteristic will be to make sure that we have a y-intercept at 0, which we already do. Okay? Now, it says it has a relative minimum. So remember, minimum is the lowest point on the graph. So it says it is of -8, so I'm coming down to -8, but it says it's at x equals 2. So right now I have my dot at x equals 1, so I should just move it over to 2. Now, you notice it's not making a graph, right? So that's because it has rotational symmetry about the origin, okay? So this point right here is -4, -8. Our origin is right here. So what I want to do is make sure that I have the same point across from the origin. So everything up here is positive, so I need to put a point at +4, +8. And you'll notice that it then makes a graph. So let's check our points. It's increasing when x is less than -2. So here's -2, and if you look to the left, everything less than, it's increasing. We have a minimum here at -8, or of -8 at x equals 2. We have a y-intercept of 0, and we have a point at -4, -8. And the rotational symmetry just means that if I took this graph and I rotated it, then I would end up on the same points, which is where +4, +8 come from. So I want you to sketch that on number 1 on your graph, okay? All right, so now I'm moving to page 2. And this time we're going to draw a graph, so it may look a little rough because I'm not the best drawer, as you know. All right, so it says, sketch the graph of the cubic function that increases from x is less than -2, and it decreases between -2 and 0, and then it increases when x is greater than 0. The function has a local max, our highest point, of 4, and a local min of 0. Okay, so unlike the first question, it does not give us the actual point, all right? So you've got to figure that out. You know that the local max of 4, all right? So we have a local max of 4, and it's going to be at -2 because it tells us that our graph increases when x is less than -2. So here's our increasing up to -2 with a maximum of 4. Then it tells us that it decreases between -2 and 0, and it also has a minimum of 0. Then it tells us it increases for x is greater than 0. So I'm taking my line and I'm going back up. So your graph should kind of look something like this. Let's hit check. All right, and we have the same points. Their graph is just a little steeper than what mine is. All right, on B, it says, how does the graph compare to y equals x cubed. Not squared, sorry, cubed. Here's y equals x cubed. You notice that this graph is strictly increasing. But you notice this graph, first it increases, and then it decreases, and then it increases again. So that's the difference in them. That's how you compare them. All right, on this one, I want you to go ahead and mark out this chart. We're just going to be looking at the graph, okay? And it wants to know the greatest relative maximum. All right, so you have a max point and you have a min point. So here's our max point, okay? Now, it's between 2 and 4. So we're going to estimate and we're going to say that it has a max of 3 at x equals. Now, this x is closest to -1. So it has a max of positive 3 at x equals 0. Now, it doesn't ask us for the minimum, but I want to talk about the minimum as well. So the minimum is down here. So this has a minimum of -8 at x equals 2. And that's one way you can do it. You can draw your line and see where they connect, okay? All right, so now I want you to mark out number 4 and number 5 on your workbook paper. And we're going to head to number 6. So, on your paper, your workbook paper, below number 6, I want you to write even equals symmetric to y-axis. And then I want you to write odd equals symmetric to the origin. Okay? All right, so now we are looking at these 4 graphs, and we have to determine if it's an odd function, an even function, or if it's neither. So this first graph, is it the same on both sides of my y or both sides of the origin? So I want you to circle the origin first. Now, when you compare the origin, you're looking to see if it's the same in quadrant 3 and 1. It is not. So it would not be odd, but since it is the same in quadrants 1 and 2, that would be even because it's the same on the y-axis. So if you took that graph and you folded it in 2, it would lay on top of one another, okay? On the second one, go ahead and circle your origin. For the origin, you're looking to see if it's the same in, and I'll add this to our notes, in quadrant 1 and quadrant 3. And if it's even, remember we're looking to see if it's 1 and 2. So, it is the same here and here. So this would be odd. All right, on the third one, circle your origin. Now, it is not the same in 1 and 3. And it's also not the same in 1 and 2. So this would be neither. The last one, we're circling our origin, and we're looking to see if it's the same in 1 and 2 or 1 and 3. I'm going to go with even because it's the same in 1 and 2. It's symmetric to the y-axis. So if you were to take that graph and fold it in 2, then it would lay on top of one another, okay? So Even, odd, neither, even. All right. Now, number 7, we're doing rate of change on 7 and 8. So, you know what rate of change is. It's just fancy for slope. All right. So, when you have 2 points, remember, you are looking for y2 minus y1 over x2 minus x1. And this is the same as the highlighted portion. This just means y2 minus y1 over x2 minus x1. Okay? It says f of b and f of a. That's because anything f of whatever, f of x, f of q, f of whatever letter you're using will be your y values. Your x values are your b and your a. And they are labeled 1 and 2 because a comes before b in the alphabet. So a is value 1 and b is value 2. So you were given 2 points. Okay? Now let's look at a. Those are going to be x1 and y1. And b's are going to be x2 and y2. So now I'm taking that information and I'm plugging it in to either equation. So first we have 5 minus a negative 3 over 7 minus 5. These two negatives become a positive, so I have 8 over 2, and that equals 4. So my slope here is 4. So now if you want to check yourself, you can start at point A and you can go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay? I want you to do B on your own. All right, let's see. Go ahead and skip number 9 and let's go to 10. All right, so this is the same thing, except you were given a function rule. You're not given the points, you're given the function rule. So, our function rule is y equals negative 10x squared times x minus 2. Okay? Now, on 10a, it gives us the interval from 0 to 1. So what I want to do is label 0 as A and 1 as B. So what I'm doing right now is I'm taking value A, which is 0, and I'm plugging it in for x. Now, once I do that, I should get a number. After I plug in A, I want to plug in B, which is 1 for both of my x's. All right, so I'm going to go over here. And I'm going to type in get it turned on. There it goes. 10. Oh, man. All right, I'm typing in my function rule, which is 10 times, it's actually negative 10. Negative 10, and I'm plugging in a 0 this time. 0 squared times 0 minus 2. So I have to plug in 0 first. So when I plug in 0, I get out 0. Now, I want to plug in a 1. Negative 10 times 1 squared times 1 minus 2. And I get 10. So, f of 0 equals 0. And f of 1 equals 10. Okay, so we're going to use the rule f of b minus f of a over b minus a. Well, we labeled a and b. So on the bottom, we know that this has to say 1 minus 0, right? Well, when I plugged in b, I got out a 10. And when I plugged in a, I got out a 0. So, 10 minus 0 is 10. 1 minus 0 is 1. So I just get 10. So now, you can check yourself and you'll see that the average rate of change is 10. So you are doing the same thing for B, except this time A equals 1.5 and B equals 2, and you are still using this same function rule. Okay, be sure to show your work. All right, I want to skip over to number 17. And I'm going to work through these with you. So number 17 is on the reinforce. So let me get to that. Okay. Now, this is even and odd functions again. Okay, so number 17. Think about how you can determine whether a function is even or odd. So we're going to do it algebraically, which means you have to work something out. And graphically would be just looking at the graph and determine the symmetry. So for algebraically, we're going to write for f of x evaluate x equals negative x and simplify. So what that means, be sure you listen here. What that means is anytime you see an x, you are plugging in a negative x. So over here I'm going to write plug in negative x for x. And I'm going to make sure I know that's important. You do that to find out if it's even or odd algebraically. So, let me erase this because I don't have enough room. Alright, so I'm saying if f of negative x equals f of x, it is even. So what that means is when you plug in this negative x for your positive x, and after you simplify, after you solve it, if it matches your original equation, then it is even. If f of x equals f of negative x, then it is odd. And what that means is when you plug in a negative x for your x, you solve, you get your answer. Then you have to go back and distribute a negative to the original. If after you distribute the negative to the original and you solve your first equation, if they match, they are odd. We're going to go over it. We're going to work them. Don't freak out. Now, you know B. If you do it graphically, remember, if it is even, if it is symmetric to the y-axis, and it is odd if it's symmetric to the origin. Okay? So now is where you really want to listen. So for this first one, remember, plug in negative x for x. So I'm going to write f negative x equals, oh, there's a positive x. So I'm saying negative x squared plus 5. All right, that simplifies to a negative x times a negative x plus 5. I'm just breaking it down for you. Two negatives make a positive, so that would be an x squared plus 5. Now, does this match this? Yes, so it is even because that's the rule that we wrote on A. F of negative x equals f of x. So we know it's even, so we don't even have to try odd. Okay? All right. Now, on B, we have a g of negative x equals, there's a positive x, so I'm saying negative x squared plus 2 times a negative x plus 4. So this is a negative x times a negative x plus 2 times negative x, which that would not be a plus now. 2 times negative x is negative 2x plus a 4. So two negatives are going to make a positive here. And we got a x squared minus 2x plus 4. Now, does this and this match? No, it does not. So, we know it's not even. So now we have to check for odd. To check for odd, you take the original. And you multiply everything by negative. So in other words, you are changing the sign. Negative x squared minus 2x minus 4. Does this and this match? Nope. It does not. So this is neither, because this does not match my original, and that was how we did even, and the odd function does not match my original. So 18 is neither even nor odd. All right, now we are going to move to the last one. And it is h of x equals negative x cubed plus 3x. So remember, we plug in a negative x every time we see an x. So all right, so what I'm going to do I'm going to bring down my negative. And I'm going to say a negative x times a negative x times a negative x minus 3x. Okay? So, an x times an x is a positive. That did not say that right. A negative times a negative is a positive. A negative times a negative is a positive. A negative times a negative is a positive. So we have x cubed minus 3x. Well, does this match my original? No, it doesn't. So it is not even. But remember, to find odd, you take your original and you multiply it by a negative. So this becomes, two negatives make a positive, x cubed minus 3x. So since this matches this, it is an odd function. Okay? So now, what you have left to do is more practice 11. Alright, what you have left to do is more practice 11 through 15. And remember the 5-question quiz that will be uploaded at 8 a.m. on Friday.